Okay, welcome back to my channel. This is going to be a video in my math playlist. So I haven't made a video in about 3 weeks, so I want to do something a little bit more simple and straightforward to get back into making videos. So I'm gonna do high school statistics for this because I just think um, well, first of all, I could use a lot of extra practice in this. It's been a long time since I've done this sort of thing. And I think this will be interesting to make public. So we're going to start the course challenge here. Okay, and then we're going to do these statistics problems. I do have a calculator. I also have a way of using scratch paper if I need it, but for now, let's just try to do the problem. So the following table gives the number of people on the Titanic by class and whether or not they survived. So it looks like we've got a table here with 4 columns: class, survived, died, and total. And we've got we've got 6 rows. The first row is just the headers for each of the columns. And then the second row is first class. Then we've got second class, third class, crew class, and finally the total row with the totals for each of the columns: survived, dead, and total. Complete the table giving the conditional distribution of class for people who survived. Round your answers to the nearest tenth of a percent. Okay, so as I said, there has been a long time before I've done these problems. I used to do them pretty well, but even so, when I did them, I never took any sort of statistics courses throughout my formal schooling. So a lot of these concepts were pretty new. But I think I remember how to do this. Conditional distribution, that's a pretty technical term there, but just kind of looking at here. So what percentage of people survived that were in first class? So for that, we can see we've got, so I guess what I need to know is how many people there were. So it looks like total, the number of people on the Titanic was this number here, 2,229. And then we can see the number of first class people were 325. And the number of first class people of these 325 people that survived were 202. The number of the 325 people that died were 123. But the number of total people on the Titanic that died, that were first class, was 123. And that's the same number of people that died of the group that were first class. So if we wanted to see what percentage of people in first class died, we would divide 123 by 325. But this appears to be asking, and again, this is a technical term that I'm not that familiar with, but it says for people who survived. So how many people survived? 713 people survived. So how many people survived that were in first class? That would be 202 divided by 713. And I think that's what they're asking. They could be asking how many people. So let's go with that. So where I could get this problem wrong is I didn't understand what the so they're asking for a ratio here or a percentage here. They're asking for people who survived as a proportion of total people. And I don't know if they mean total people on the ship, total people who survived, or total people in the respective class. But I'm going to go with survived divided by total. So for here, it's going to be 202 divided by 713, which I will use a calculator for. Oops, 202. Okay, and we're going to round this to the nearest tenth. So this is a 4 or below, so it gets rounded down. So it's going to be 28%. Of the people that survived, 28% of the people who survived were in first class. All right, now of the people who survived, what percentage of the survivors were in second class? Which is what I'm assuming this question is asking, but again, I could have that wrong. So, but we're gonna fill those in like that and see if we get that right. If it's wrong, we'll check the explanation and see why it was wrong. Undoubtedly, it was because I misunderstood what I was being asked. All right, so to get the percentage in second class, we do 118 divided by 713. So of the total people that survived, what percent of those people were in second class? So to figure that out, we do 118 divided by 713. And we see, because this is a 5 here, it gets rounded up, so we have 17%. All right, so let's do the same thing for third class. Okay, it gets rounded up 25%. And then the crew class. Okay, and 30%. So I'm not sure if these are real numbers or not, but the results are actually pretty interesting. I would have expected there to be more survivors in like first class because they get like priority to lifeboats or something like that, or like a position in the boat that is more advantageous. But to have the second class be the lowest and then the lowest class be the highest, it's kind of a surprise. But again, I don't know if these are real numbers or not. Let's see if I got this correct. And I didn't. So I think I misunderstood what I was being asked. Let's get help. So I didn't misunderstand what was being asked. I did everything correct. I just misread that the answers needed to be rounded to a nearest tenth of a percent. I was thinking it needed to be rounded to the nearest whole percent. I didn't see this and I didn't interpret it correctly. So that's okay. I was very nearly there. The point of this video is I'm just really scatterbrained. Obviously, I actually started and stopped multiple times before even making this one. So I'm just trying to get my brain back into working mode here after the vacation. Okay. So, okay. Okay, so it's going to be a tenth of a percent. So this is the key number to look at when it comes to rounding. This number is 4 or lower, so it gets rounded down. This number stays the same, so now we've got 28.3. Okay. Okay, so same deal here. It's 4 or lower, so 16.5 is the answer. Okay, so third class is going to be 178 divided by 713. Okay, so this number is 5 or higher, so it gets rounded up. This gets rounded up again, so we've got 25.0. All right, final one. I feel like I should be, one thing I could do to make this more interesting to my audience and make it easier on me, I think is use Python as my calculator. I think that would be a lot more relevant to this channel and get people much more interested. So after this problem, I'm going to switch over. I'm going to stop using this calculator. I'm going to start using the Python interpreter shell to do my calculations. Okay, so 30.2. All right, so hopefully this is now correct. Aha! One of the kind of most difficult things about math for me is that quickness and that second guessing where you exactly what we saw here. I didn't read this and I got it wrong even though I knew exactly what they were asking. All right, just kind of faith and trust in the answer is something I often struggle with, which is not necessarily a bad thing, it just slows me down a lot. Okay, so Rosa's friend Jake claims that he can read minds. To test Jake's abilities, Rosa chooses 3 different numbers, 1 to 10. Rosa then asks Jake to identify which 3 of the 10 numbers she chose in the correct order. Assume that Jake has no special abilities and is randomly guessing the numbers. What is the probability that Jake correctly identifies all 3 numbers in the correct order? So I remember, even though it was probably years ago by now, I remember there is a probability formula where the order, there's 2 formulas. There's one you use when the order does matter, and there's one you use when the order doesn't matter. And I forget the formula. So yeah, I don't really want to guess because I remember doing this and I remember having this kind of question pretty well learned at one point, but unfortunately I have forgotten it. 3 different numbers. Which 3 of the 10 numbers should show us in the correct order? I feel like, I think it has something to do with factorial. Like if you do, yeah, you know what? I don't know how to do this, so shoot. I wish there was a way to just flag it as I don't know and I need to practice it, but it looks like there isn't. So, you know what I'm going to do, I think, is let me try this. I'm just going to choose the first answer here, and hopefully that is wrong. Yep, that's wrong. And then I'm going to get help. Okay, yeah, I remember this probability equation here. So our probability will look something like this. Probability equals the number of correct sequences divided by the number of possible sequences. Since Rosa is choosing 3 different numbers, we can use permutations and combinations to help us find the counts in the numerator and or denominator. The most important thing is to distinguish whether or not order matters in the given scenario. If order matters, we use permutations. If order doesn't matter, we use combinations. So remember from up here, it says that order does matter, so we're going to use permutations instead of combinations. So, and here are the two formulas I remember. So we've got a formula for permutations, and we've got a formula for combinations. So we've got P and C. So here are the permutation and combination formulas when we select our items without replacement from a set of n distinct items. Yeah, and I was right about factorial being a big part of this. I just didn't remember the equations, and I didn't remember the underlying reasoning for how these are solved. But we can see we got a difference here for permutations where order does matter. We've got the n factorial divided by n minus r, the result of that, factorial. But then if the order doesn't matter, you use combinations, and it's the same, n factorial divided by the result of n minus r factorial times r factorial. Permutations or combinations, we want the probability that Jake guesses the correct sequence. That means Jake needs to identify the numbers in the correct order, so order matters. So we should use permutations to get the counts in the numerator and denominator. Counts. If order matters, there are now here it's getting tricky. It looks like there's a syntax here that I'm not familiar with. We've got a I guess I would call that a subscript 10, and then we've got a capital P and a subscript 3, and I'm not sure if subscript is the correct word. We just got a number 10 that looks like it's below the rest of the characters in that sentence. But it looks like 10 stands for the range. So it can choose, you can choose a number 1 or 2 or 3 all the way up to 10. So that means you've got 10 choices of numbers. You can choose 1, 2, 3, 4, 5, 6, 7, 8, 9, or 10. So you have 10 different choices of numbers. So that's what that 10 stands for. And then you've got the P, which stands for a permutation, which means that the order does matter. And then you've got 3, which stands for the different numbers that Rosa chooses of those 10 available choices. Now, I think there's also a difference for if Rosa can make choices of the same number. That would choose, I think, the number of choice. That would change the number of choices you can make, or something like that. I don't remember exactly. If order matters, there are 10 P3, so we can see 10 is our number n. P means that the order does matter, and 3 is our number r here, so we can see how to plug that into the equation. Total ways to select 3 numbers without repeats from 10 numbers, and that's without repeats. Jake is trying to identify all 10 of the numbers in the correct order. We don't need to use permutations to count here exactly one of the total possible sequences is the correct sequence. We can calculate 10p3 directly with most calculators, or we can use the permutations formula. Oh, okay. It looks like what they're saying is that calculators have built into them the... So if I were to go to advanced mode, I don't see it. I guess I don't know what they're talking about there. Maybe, is there a probability? Nope, don't see anything like that. Okay, so I'm not sure what they're talking about there. So we're gonna ignore that, and we're gonna do the we're gonna plug it into the formula. So let's go back up to the formula, and then let's plug the numbers in. I'm gonna pause the video, and when I come back, I'll have so that I can write with a paper or pencil. I'll plug those numbers in. All right, I'll be back soon. All right, I am back, and I'm gonna use the tried and true app.sketch together. So app.sketchtogether.com. And then I like to use the free version. I've logged in and tried to not use the paid version, but I've tried to use it while logged in, and I've had more difficulty doing that than just remaining logged out. You only get an hour, but I typically need an hour break. I typically need a break after an hour anyway, so that's not really a deterrent. If it were like 15-20 minutes, that would be not enough time, but we've got a full hour here. So, yep, so now you can see me writing right there. So I will try to do the formula from memory. I think that's going to be the best way to do it long term. And we'll see what the difference is between what I remembered and what it actually is. I've got some dirt on my screen I would like to clean up. Okay, there we go. All right, so for memory, we've got the number n, and then we've got this order does matter, and then we've got the r. So I'm not seeing that on my screen. Huh? Yeah, that's interesting. I'm not seeing that on my screen. Oh, it's probably over here. Yeah, there it is. Okay, perfect. So, and then we've got. Since the order does matter, we've got n factorial divided by the result of n minus r factorial. And that's the whole equation. It's going to be a little bit different if the order does not matter. I can't remember if the other one is this is a permutation. Yeah, if the order does not matter. The other one is a combination. Okay, so let's plug those numbers in. The numbers are going to be over to the left here. We're going to use the real numbers. So we've got 10, P3. 10 is the N, 3 is the R. So we've got 10 factorial divided by 10 minus 3 factorial. So simplified, that's 10 factorial divided by 7 factorial. So now I can use a calculator for this, but since I'm already here using my sketch pad here, I will just do that. I'll just continue doing that. So hopefully this is visible. Yep, that's visible. So let's just write it out because it's pretty easy numbers to work with. So 10 factorial is the equivalent of 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And this is 7 times 6 times 5. So that's all going to be the same. So it's a lot more simplified now. It's just 10 times 9 times 8 is going to be the answer. 9 times 8 is going to be, 9 times 9 is 81. So 9 times 8, we're only going to times it by 9 8 times instead of 9 times. So it's going to be 81 minus 9. 81 minus 10 is going to be 71. but we're going to minus it by one less value, so the answer is going to be 72. So, and then 72 times 10 is 720. So, the answer is going to be 1 over 720. Yeah, so that's the probability that all three numbers are in the correct order, 1 in 720. So this, yeah, this gives you, okay. Yeah, so the probability equals, so this what we did here was not to find the probability. So the probability does not equal 720. What equals 720 is the number of possible sequences, 720. The number of correct sequences, there's only one correct sequence. So trying to match the one sequence that was drawn. So there's only one correct sequence. Number of possible sequences is 720. So the probability is that one correct sequence divided by the number of possible sequences, which we know is 720 because the number of possible sequences is equal to the total number of options factorial divided by the result of the total number of options minus the total number of choices factorial, which in our case is 720. All right, it's starting to come back to me. I'm starting to feel a little bit more warmed up now. We'll try to get to see if I can do another like IT related video today, but I just want to kind of warm myself up, get used to making some videos and kind of thinking deeply about stuff before I dive into more of the core content for this channel. So the next question is, an airline company wants to survey its customers one day, so they randomly select 5 flights that day and survey every passenger on those flights. What type of sample is this? So this is another one where I'm not I just don't remember this. This is just beyond me. So I'm tempted to try to get the wrong answer and do what I did with the last question, because I just don't know the right answer, and I think guessing and getting the right answer would be kind of detrimental to me actually learning this concept. But at the same time, this is not the appropriate place to learn this. This is just the course challenge to kind of prove that you've already learned it. So the other thing I could do is exit out of the course challenge and just go through the exercises. But I think it's this. So, okay, so I was very wrong about that. Let's get some help here. So, okay, so it's not, yeah. So an airline company wants to survey its customers one day. So they randomly select 5 flights that day and survey every passenger on this flight. So it's not a simple random sample because they're choosing I guess I would think now, knowing that this is wrong, my second guess would be this cluster random sample. So not every subset of passengers had the same chance of being selected. So this is not a simple random sample. Simple random sample, a sample of n individuals chosen so that every group of n individuals has an equal chance of being in the sample. Stratified random sample, we divide the population into groups called strata, then sample some individuals from every group. A stratified random sample is helpful when we expect that there may be substantial differences between the groups. Cluster random sample, we divide the population into groups called clusters, randomly choose some of the groups, and we include every member in those groups in the sample. A cluster random sample is helpful when each of the groups is similar to the population. Systemic random sample, we put the population, or it comes to us in some ordered arrangement. We randomly select one of the first k individuals and choose every kth individual from that point on in the arrangement. Note that these aren't all of the sampling methods people use. For instance, there are convenience samples. We select individuals who are already readily available or easy to reach, and voluntary response samples. We give a general invitation and allow people to choose to be in the sample, but these methods are likely to produce biased results. The passengers were divided into groups, flights, and the company sampled every passenger on some of the groups. Okay, perfect. So this is a cluster random example. Looks like we've got some stuff to watch. I'm kind of curious to watch this one because this is pretty new to me, so I might do that. In the meantime, let's select this cluster random sample and do a check again. And then we'll go back and read. An airline company wants to survey its customers one day, so they randomly select 5 flights and survey every passenger on those flights. So yep, that's a cluster random sample. Let's go to the next question. But before looking at that, let's watch this video.
Let's say that we run a school,
and let's watch it at
there is a population
double speed
of students right over here. That is our population. And we want to get a sense of how these students feel about the quality of math instruction at this school. So we construct a survey, and we just need to decide who are we going to get to actually answer this survey. One option is to just go to every member of the population. Let's just say it's a really large school. Let's say we're a college, and there's 10,000 people in the college. Well, we can't just talk to everyone. So instead we say, let's sample this population to get an indication of how the entire school feels. So we are going to sample it. We're going to sample that population. Now, in order to avoid having bias in our response, in order for it to have the best chance of it being indicative of the entire population, we want our sample to be random. So our sample could either be random, or not random. And it might seem at first pretty straightforward to do a random sample. When you actually get down to it, it's not always as straightforward as you would think. So one type of random sample is just a simple random sample. So simple random sample. And this is saying, all right, let me maybe assign a number to every person in the school. Maybe I already have a student ID number. And I'm just going to get a computer, a random number generator, to generate the 100 people, the 100 students. So let's say there's a sample of 100 students that I'm going to apply the survey to. So that would be a simple random sample. We are just going into this whole population and randomly, let me just draw this. So this is the population. We are just randomly picking people out. We know it's random because a random number generator, or we have a string of numbers or something like that is allowing us to pick these students. Now that's pretty good. It's unlikely that you're going to have bias from this sample, but there is some probability that just by chance, your random number generators happen to select maybe a disproportionate number of boys over girls, or a disproportionate number of freshmen, or a disproportionate number of engineering majors versus English majors. And that's a possibility. So even though you're picking a simple random sample, it's truly random. Once again, it's some probability that's not indicative of the entire population. And so to mitigate that, there are other techniques at our disposal. One technique is a stratified sample. Stratified. And so this is the idea of taking our entire population and essentially stratifying. So let's say we take the same population. I'll draw it as a square here just for convenience. And we're going to stratify it by, let's say we were concerned that we got an appropriate sample of freshmen, sophomores, juniors, and seniors. So we'll stratify it by freshmen, sophomores, juniors, and seniors. And then we sample 25 from each of these groups. So these are the stratifications. This is freshmen, sophomore, juniors, and seniors. And instead of just sampling 100 out of the entire pool, we sample 25 from each of these. So just like that. And so that makes sure that you are getting indicative responses from at least all of the different age groups or levels within your university. Now there might be another issue where you say, well, I'm actually more concerned that we have accurate representation of males and females in the school. And there's some probability, if I do 100 random people, it's very likely that it's close to 50-50, but there's some chance, just due to randomness, that it's disproportionately male or disproportionately female. And that's even possible in the stratified case. And so what you might say is, well, you know what I'm going to do? There's a technique called a clustered sample. And let me write this right over here, a clustered sample. And what we do is we sample groups. Each of those groups we feel confident has a good balance of male females. So for example, we might, instead of sampling individuals from the entire population, we might say, look, on Tuesdays and Thursdays, and this, well, even there, because it's not a trivial thing to do, let's just say that we can split our population into groups. Maybe these are classrooms. And each of these classrooms have an even distribution of males and females, or pretty close to even distribution. And so what we do is we sample the actual classrooms. So that's why it's called cluster, or cluster technique, or a clustered random sample, because we're going to randomly sample our classrooms, each of which have a close or maybe an exact balance of males and females. So we know that we're going to get good representation, but we are still sampling. We're sampling from the clusters, but then we're going to survey every single person in each of these clusters, every single person in one of these classrooms. So once again, these are all forms of random surveys, or random samples. You have a simple random sample, you can stratify, or you can cluster, and then randomly pick the clusters, and then survey everyone in that cluster. Now, if these are all random samples, what are the non-random things like? Well, one case of non-random, you could have a voluntary survey or voluntary sample. This might just be you tell every student at the school, hey, here's a web address. If you're interested, come and fill out this survey. And that's likely to introduce bias because you might have maybe the students who really like the math instruction at their school more likely to fill it out. Maybe the students who really don't like it more likely to fill it out. Maybe it's kids who have more time more likely to fill it out. So this has a good chance of introducing bias. The students who fill out the surveys might be just more skewed one way or the other because just they volunteered for it. Another not random sample is what we call a You're introducing bias because of convenience, is the term that's often used. And this might say, well, let's just sample the 100 first students who show up in school. And that's just convenient for me because I don't do these random numbers, or do stratification, or doing any of this clustering. But you can understand how this also would introduce bias. Because the first 100 students who show up in school, maybe those are the most diligent students, maybe they all take an early math class that has a very good instructor, they're all happy about it, or it might be the other way. The instructor there isn't the best one, so it might introduce bias the other way. So if you let people volunteer, or you just say, oh, I'm going to go to the first N students, or you say, hey, let me talk to all the students who happen to be in front of me right now. They might be in front of you out of convenience, but they might not be a true random sample. Now, there's other reasons why you might introduce bias, and it might not be because of the sampling. You might introduce bias because of the wording of your survey. You can imagine a survey that says, do you consider yourself lucky to get a math education that very few other people in the world have access to? Well, that might bias you to say, well, yeah, I guess I feel lucky. While the wording was, do you like the fact that more students at your school tend to fail algebra than our surrounding schools? Well, that might bias you negative. So the wording really matters in surveys, and there's a lot that would go into this. And the other one is just people's, called response bias. And once again, this isn't about response bias. And this is just people not wanting to tell the truth, or maybe not wanting to respond at all. Maybe they're afraid that somehow their response is going to show up in front of their math teacher or administrators, or they're too negative, it might be taken out on them in some way, and because of that, they might not be truthful. And so they might be overly positive or not fill it out at all. So anyway, these are just a very high level overview of how you can think about sampling. You want to go random because it lowers the probability of introducing some bias into it. And then these are some techniques. And also think about whether you're falling into some of these pitfalls that have a good chance of introducing bias.
Okay, I actually didn't get a lot out of that, unfortunately. Basically, my takeaway from the last question is that to pass that section of the educational materials, I need to know the difference between those listed survey techniques. So for now, let's just continue on with the next one. I did do some of this in the past, so some of these might be familiar to me. This actually looks like it might be familiar. So Joe sells cars. He recorded the age and years of each car on his lot, along with the number of kilometers it had been driven. After plotting his results, Joe noticed that the relationship between the two variables was fairly linear, so he used the data to calculate the following least squares regression equation for predicting distance driven from the age of the car. What is the residual of a car that is 2 years old and has been driven 50,000 kilometers? Okay, so you know what? I'm gonna stop this here because this is just. I'm sure. Now, if we look back at, because I've had this account for years and years and years, if we look back at my percentages, we can see I've only touched on this 33%. So let's go to third grade math, and let's just try to get this up a bit. And I'm going to cut this video off at 1 hour. This video was just meant to be kind of a warm-up for me to make more core content for this channel, more IT stuff, maybe read an RFC or work on some of the books I've been reading through, or do something in my lab. So we're going to go back to third grade here. We're going to look at the sections where I don't have full mastery points. So here's one for understanding fractions, and we're going to try to get full mastery points in this section. So we can take the UNIST test and we can get 300 mastery points. So let's do that. Okay, so what does the 10 represent in 6? So we've got a numerator and a denominator. The 6, if we can think of this as a pi, we would have 1 pi. So we can think of this as having the number of equal parts in all of the wholes. The number of equal parts in one whole, the number of parts we are counting. Oh my god. So let's simplify this. Let's not think of it as 10 over 6, and let's think of it as 1 over 2. So 1 over 2, that is 1/2. So the total, if we were to think of this as a pizza or a pie, and we were to think of it as 1 over 2 instead of 10 over 6 to simplify it, the 2 would, the entire thing would represent the entire pi. The 2 would represent the way it's been divided. It's been divided into 2 pieces, and then the 1 represents the number of those pieces that we're counting. So we would get half the pi if we had the fraction 1 over 2. If we had the fraction of 2 over 2, we would have the entire pi. If we had the fraction of 3 over 2, we would have the entire pi, plus there'd be another pi, and we would have half of that. So the 1 in that case would represent the number of parts we're counting. So that's going to be the same for this fraction. There we go, and I got it right. Let's move on to the next one. The large rectangle is equal to 1 whole. What fraction of the rectangle is shaded? I'm assuming that the shading is in the darker color. That's how shade usually works. Darker color is the blue color here. So we've got 1, 2, 3, 4 out of 5, 6. So we can simplify that. But it looks like they don't need that. So we've got 4/6. All right, on to the next one. The pie is cut into 3 pieces. Is each piece equal to 1/3 of the area of the pie? So we don't know exactly if that's the case because it doesn't say here if it's cut into 3 equal pieces. According to the picture here, it appears as though it is. And I don't think this is meant to be a trick question, so I'm going to answer yes. But just based on the information here, one of these could be slightly bigger, one of these could be slightly smaller. So I would say no, but knowing what I know about this level, this being the 3rd grade level, and what they're trying to teach, fractions and things being cut into pieces, I would answer yes. There we go, and I got it right. Each circle represents 1 whole. Which fraction does the shaded area represent? So let's count the parts. So we've got 1, 2, 3, 4. So this is 8. And this is, we've got 2 of that. So we've got 16. So the bottom number is going to be 16. And the shaded parts, 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 out of 16. There we go. Whoops. So got a problem here. So now I do have a proper fraction here. I think the problem might have been each circle represents 1 whole. Okay, so total area shaded represent. Okay, I think the problem here, I'm just going to get help on this. So the numerator is the number of equal parts being counted. So there are 16 equal parts. Of those equal parts, 9 are being counted. The denominator is the number of equal parts in one whole. Okay, so this, yeah, I knew that I was not taking this part of the question into consideration, but I just didn't know how I wasn't taking it into consideration. Where I was not taking it into consideration is I was considering these two quantities to be one whole and not one of these quantities to be one whole. So you can see the answer I got was less than 1. So it was less than one whole because the number of shaded portions are less than the quantity of portions when you have both of those wheels constitute one quantity. But if you only have one of those wheels constitute one quantity, then the number of shaded regions are above the amount in one of those wheels. There's actually 9 shaded portions, but our whole number of shaded portions is 8. So our fraction should be greater than 1. So that's how I wasn't interpreting this part of the question correctly. So without reading the rest of it, I know that the answer is 9 divided by 8. Okay, so that was a bit fuzzy for me, so that's good. I need a little bit more work on that. So we're gonna move the dots to 5 over 4. So here we've got 1, 2, 3, 4, 5. That looks like an easy one. Yep, that's more of like a freebie. On the Sharks dive team, there are 3 divers in 3rd grade. There are 8 total divers on the team. What fraction of Sharks dive team is in the 3rd grade? Okay, so on the Sharks dive team, there are 3. Okay, so of the 8 total divers, 3 divers are in 3rd grade. So 3/8 of the divers are in 3rd grade. Perfect. Each rectangle is one whole. Which expressions describe the shaded part of the picture? So this one's easy. We can see the entire picture is shaded, and there's only one rectangle here for one whole. So one whole is shaded. Oh, well, okay. Wait, what? Oh, 2, okay. I have to choose 2 answers. So this is the same here as one whole, is the same answer. So yeah. Okay, so that's correct. Let's read the explanation for this one because it's not incredible. It's not like entirely. Okay, so you can just write it differently. You can have the denominator be for each of these halves, and then if you have 2 halves and you've got 2 shaded in, that's the same as one whole. So this answer is also correct. It would be incorrect to say this because even though you've got the whole here and you've got 2 shaded in there, you're now having the whole represent something so that there would actually be more shading than just for this one image here, and that's not what we're seeing. All right, so let's go to the next one. At what number is point A? Okay, so we know that this is halfway to this, so If we divide this by 2, we know what number this is. So we've got 2 over 1 would be the answer to that. So this is wait a minute. No, that's not going to be the answer. So let's not think of this as a fraction. Let's think of it as a let's simplify this. So this is going to be 2. So this is going to be 1. So 0.5. There we go. Select the two fractions that are equal to 1. This one should be pretty easy. There we go. That's a freebie. Which figure has 1/4 of its area shaded? This is another freebie. Move the dots to 5/8. Okay, so we've got 8 divisions on this line because that's what this 8 stands for. This entire thing represents a whole. This is the number of divisions of the whole, and this is the number of divisions that we are counting. So let's count them. 1, 2, 3, 4, 5. All right, on to the next one. At which point is at 1 on the number line? Okay, so this is a little bit tricky here. So we've got 1/3. So let's count this. So here's 1/3. So this would be 2/3, and this would be 3/3. 3/3 is 1 whole. So the answer is going to be B. All right, and that's it. Looks like I leveled up on 3 skills. Leveled down on 1, that's okay, but I did earn some energy points. So it looks like the video right now is at 52 minutes. So I can do something else, I think. So it looks like if I'm interested in achieving 100% mastery, I can take the unit test again. The other thing I can do is collect 50 mastery points. I might be interested in that. Let's try just taking it again and see if I can, because now that I'm a little bit more warmed up. Okay, so at what point is 9/4 on the number line? So we know this, if we've got this representing wholes, we know that it's got to be divided into 4, so we know B is incorrect. So our answers are between A and C. So 9/4, we know it's greater than 1. It's actually going to be greater than 2 as well. So it's going to be C. We can see we have 1, 2, 3, 4. 4 times 2 is 8, so 9. The answer is C. Okay, so move the dots to 1 on the number line. So we've got it in thirds. So 1, 2, 3, and then here's the 4th third, so it's going to be there. Move the dot to 1/2 on the number line. So in order to do that, we've got to create 2 divisions in our number line. So we've got first division here, second division there, and we're going to place the dot after the first division. Beth ate 6 pieces of a chocolate bar. The bar was split into 8 equal size pieces. What fraction of the chocolate bar did Beth eat? We know the bottom means how many pieces it was split into. So we know that A is incorrect. So we've got the choice between these. She ate 6 of the pieces, so we know the top number has to be 6, and there's an answer. What does the 4 represent in 3/4? The number of equal parts in one whole. Yep, and we know it doesn't represent the number of equal parts in all wholes. That's what I got wrong before. It's just the number of equal parts in a single whole. And then if we have a number on the numerator here that is higher, we know that there are more than 1 holes. Each circle is equal to 1 hole. Which images show 3/2 shaded? Okay, so each circle is equal to 1 hole. So we're going to have more than one shaded. And then we're going to have each of our holes are going to be split into 2 halves. That's what this 2 means. So we know that A is not correct because each of our holes is split into 3 parts. B is not correct either because we've got each of our holes split into 3 parts as well. So our answers are between C and D, where each of our holes is split into 2 parts. But we're going to have 3 of those parts shaded. So here we've got 3 of our parts shaded, but we added an extra part, even though we could have shaded one of our existing parts. So we don't get to do that. When we count on a number line, you don't get to just randomly go 1, 2, 10, 11, 12. You have to count sequentially. That's just how math and numbers work. So this is going to be incorrect, and our correct answer is here. We've got 1 hole here is one of these circles, and then this bottom number we know is divided into halves, and then this top number we're going to shade 3 of those halves. So here's 1, 2, 3 shaded portions of this whole circle that is divided into halves. Oh no. Oh, okay. Well, that's interesting. I guess this is a correct answer. Yeah, it must be this. Oh, that's okay. That actually took me by surprise. Let's look at the step-by-step solution and let's see what the explanation of that is. So the numerator is the number of equal parts being counted. The denominator is the number of equal parts in 1 whole. The numerator is 2, so we need 2 equal pieces in each whole. The numerator is 3, so we need 3 equal parts shaded. The following images show 3 shaded parts in a whole quantity that has 2 equal halves. Yeah, I mean, it does. This shows 3 shaded parts, 1, 2, 3, in a whole quantity here that has its that is split into halves. So here's one whole quantity that is split into halves. Here's another whole quantity that is split into halves, and we can see 1, 2, 3 shaded parts. Same thing is true for the other answer. Here's one quantity split into halves, and then we've got 2 more, and we've got 1, 2, 3 shaded parts. So it looks like another answer, if I may do that here, to this question would be something like this, where we have 1, 2, 3, 4, 5 whole parts, each split into halves. But now we have 1, 2, 3 shaded in. So that would be a fair answer to that as well. Okay, so each circle is 1 whole. Which fraction describes the 2 holes? So we've got 1 hole here is divided into 4, so we've got to have a 4 on the bottom, and then we've got 8 shaded areas, so it's going to be 8/4. The following circle is equal to 1 whole. Which fraction of the circle is shaded? So it's 1 whole, so a whole is equal to a numerator over a denominator. The denominator is the amount of equal divisions in the whole. So we've got 1, 2, 3, 4, 5, 6, 7, 8 equal divisions. So we know the bottom part is going to be 8. And then the top number is the number of those divisions that we are counting, or that in this case are shaded in. So we've got 1, 2, 3, 4, 5 of those. So the answer is going to be 5 over 8. Which fraction of the area of the rectangle is shaded? This is a freebie, 1 over 4 for everything I mentioned in the last section. Last question means true in this question. Which rectangles have 1/3 of their area shaded? So that counts, that counts, that counts. But this does not count because even though it is split into 3 parts, the parts do not appear to be equal parts. So that is not what this number means. It means equal parts, so this is not a correct answer. Got 2 more here. What fraction is located at point A on the number line? So here's our 1. We've got 1, 2, 3, 4, 5, 6, 7, 8. So it's divided into 8. So that's our denominator. And then this is the 1 to 3rd part. So 3 over 8. Okay. At what fraction could represent A? So there's going to be multiple answers. So this one here, so it looks like it's about, okay, this is interesting. So we know that these 2 answers can't be correct because 6 over 6, that would be a whole quantity of 1 here. 9 over 2, that would be on this side of the number line. So even though it appears that it's 1/2 and we don't have that as a choice, we know that maybe this could be distorted in some way. We don't know what this number is. Maybe this could be 100 here and this could go to 1, but on this side it's 1 going to 2. But we know just by nature of how fractions work that it's going to be on the left-hand side of this number line because it's going to be less than 1. All right, so it looks like we got 1 skill that's still not tested yet, so I'm still at 97%. So it looks like I can do this 1 more time and get 100% mastery. So I'm gonna do that because that's my goal, is to get, one of my life goals has always been to get 100% mastery in all available Khan Academy stuff, just because I think that, you know, that would make a lot of my other goals easier. Yeah, let's chip away at that goal right now by taking this 1 more time and hopefully getting mastery in this 3rd grade section. So what does the numerator of the fraction 4 over 3 mean? So it means we're counting 4 parts. Each large square represents 1 whole. What fraction does the total share area represent? So it's going to be 1, 2, 3, 4 halves. There we go. At what number is point A? So we've got 5. So these are all halves. So 4, 3, 2. So this is going to be 1/2. Oops, and looks like my keyboard's kind of not reliable. There we go. Which figures are divided into equal parts? So yeah, I mean, again, this is they'll be getting into geometry later, where you've got to prove that they are equal parts based on the angles given and all. And I've done that before, but I'm coming back to that. Well, I might want to do this on this channel. I can make, especially going into 2022 with like Omicron variant and like, you know, who knows what's going to happen in 2022. So I might have more time for daily videos. So okay, but for now, this looks like the correct answer without any sort of extra, with it being at the 3rd grade level. Once we start getting to geometry, we'll have to do more than just eyeball it. What fraction is equivalent to 3? There we go. Move the dot to 1, so we've got 1/4, 2/4, 3/4, 4/4. That's a whole quantity of 1. At which point is at 4/6 on the number line? So we need to have it divided into a 6. 1, 2, 3, 4, 5, 6. So we right away know that C is not correct because it's not divided into sixths. We know that B is not correct because that's the third quantity. So here we go. Mrs. Jones ordered 5 cheese pizzas and 1 pepperoni pizza. She ordered a total of 6 pizzas. Which fractions of pizzas are cheese? Okay, so 5 of the 6 pizzas are cheese. Which circle is equal to 1 whole? Oh, each circle is equal to 1 whole. Which images show 1/3 shaded? This one does, and this one does. Okay, and that's it. What fraction is located at point A on the number line? So we got 1, 2, 3, 4, 5, 6. So we know it's divided into 6. And then looks like we've got 7, quantity of 7. Min Yoon is painting 3 equal-sized sections of his canvas. So far he has painted 1 section. What fraction has he painted? That's freebie 1/3. Okay, so 1 is definitely greater than 1/2. All right, and it looks like they still haven't tested me on one of the skills, but I'm now at 100% mastery, which was the goal. So let me get that nice 100% popping up there before I move on. Oh, you know what? It was 100% mastery in one of the, yeah, in one of these units. So that took me from 90% to 92% for 3rd grade math, which I think I'm going to call good for now. As I said, this was just kind of to get me back into making videos and kind of getting my mind working without hopefully doing stuff that comes like a lot easier to me too, and not getting frustrated. So all right, so thanks for watching. I hope this video has been inspiring. One of the things I want to do on this channel is just get people excited about self-learning and kind of get over, because I think when it comes to formal education, a lot of people walk away from things like math and just with this idea that like it's just not for them. And I just think today, with all these new tools we have in the internet and stuff, people need to give it another try and just use like Khan Academy. There's another Brilliant.com is like a paid one, because if math isn't for you, I do believe there are people that have like a form of dyslexia for numbers, where like I believe that there legitimately are people who just doing math or working in a math oriented field isn't for them, but even people who have dyslexia can learn to read and write, I think. Just to say, I swear off math, I'll never do it again because I have dyscalculia, or whatever it's called, probably isn't the right approach in my opinion. And this might be able to help somebody who would like to learn math. But I'm not going to get into that right now. I'm just going to end the video because this has been going more than an hour. So thanks for watching, and I'll see you in another video, hopefully another one today, where I do more of the core content for this channel.